Alright, so in this video we're going to be talking about chemical equations. So here's an example of a chemical equation. There are lots of different types, but we're going to break down the different pieces of a chemical equation. Some will look familiar from talking about chemical formulas, but some are going to, parts are going to be definitely new for us. So first off, we have chemical symbols. We have been working with these for months now. We have the symbol that represents whatever element we are talking about. So in this case, we have H's and we have O's, which means we have hydrogen and oxygen. We also you may have chemical formulas. So in some cases, you're going to have a whole compound. So maybe it makes a compound. Maybe you have to have a compound to have the reaction happen. But sometimes you're going to have singular elements as symbols, and sometimes you're going to have compounds in the form of a formula. Now, a word that we have not talked about yet is the reactants. So anything that is before that arrow in a chemical equation is the reactant. It is what is reacting, hence the name. So in this case, we have H2 and we have O2 reacting together in this chemical equation. So that's what's happening in the reaction. That's what has to go into the reaction. Now, the part that comes out of the reaction is called the product. That's what is being produced. So anything to the right of the arrow, that's the product. So in this case, we have H2O, or water, being produced in this chemical reaction. So reactants are what react, the products are what are produced. So names kind of go with what they mean there. Alright, this arrow in the middle means yields. So it's kind of like an equal sign, or it's saying we're going from this to this, so from the reactants to the products. So yields is another way of saying what's, it's producing this. So just so you're aware of what that means. The subscripts. So we have talked about this before with chemical formulas, but just as a reminder, our little subscripts there, they are telling us how many atoms of that element there are. So in the one that's pointing to there right now, that means there's 2 atoms of that hydrogen, there's 2 atoms of that oxygen, and there's 2 atoms of that hydrogen in that case. And remember, if there's no subscript, it means there's just 1 atom of that element. Something that we have not seen yet, because it's only in our chemical equations, are coefficients. So you may notice these numbers here, these big numbers in front of a couple of our compounds or elements. They're not going to necessarily be in front of all of them, and some equations might not have any coefficients. But basically, what that's telling us is how many of each molecule we have. So there's a 2 in front of the H2. That means we have 2 molecules of H2. We have 2 molecules of water in this case. And we're going to talk here about balancing equations and how basically we have to have the same number of atoms on each side. So we'll get to that here. But this is just so you know how to read your equations. So before we get to balancing equations, we have to talk about the law of conservation of mass. So mass cannot be created or destroyed just out of nowhere. You can't have matter appear out of nowhere, and you cannot have matter just appear into thin air. It's got to go somewhere. It may change form, but it's got to go somewhere. So when you have a chemical reaction, you're always going to have the same number of atoms of whatever you're reacting as you do in the products. So in that last equation, which is one we're going to be looking at, we had the same number of hydrogen and the same number of oxygen on our product side as we did the reactant side. So the total mass is going to be equal for both products and reactants, no matter what chemical equation it is. So we're going to be learning to balance equations by inserting coefficients into equations to show the correct representation of that reaction. Because if you don't have a balanced equation, it's not actually showing you the correct version of that reaction, because there is no, you're not going to know how many molecules of each reactant or product are actually needed in that for that to occur. So let's look here. So this is the one we were looking at, and you can notice there's no coefficients in there like there were before. But right now this equation is not balanced. If you look here, and let me get my marker ready, and I know my circles are going to be awful, so you can save pointing that out to me later. We have 2 hydrogen atoms here on the reactant side, and we also have 2 oxygen atoms on the reactant side. So we've got 2 and 2. On the product side, we have 2 hydrogen and we have just 1 oxygen. So you can see our hydrogens, we have the same amount on both sides of the arrow, but our oxygen, we are off by 1. So that means we have to balance this. So like we said, they're uneven, but when we are going to put in coefficients, which are the numbers that go before the compound, you never put them in the middle of a compound. Like you would never put the coefficient in here, even though our oxygens are what are unbalanced, because this H2O, that's a whole compound. You can't just change the number of atoms. So we always put our coefficients out front, in front of these if we need them. So we're going to practice doing that here. All right, so we have our equation. And when we first start, here, let me go back. When we first start working with these, I think it's useful to make a chart when you do this. So it's useful to make a chart of the number of atoms on the reactant side, which is what that R stands for, and number of atoms of the product side, and then to list for each element. And then as you work through, you can cross things out and then figure out what you have there. Now, as you get better at this, this is a process. For some people, it comes super naturally. Some people, it takes a lot of practice. It just really depends on what kind of brain you got. How, some people are like puzzles and some people despise them. It's almost kind of like a puzzle, and it takes a lot of trial and error. And we're going to work a lot with this in class. But I think making a table for anybody, no matter how naturally it comes to you, is a good way to start. And then as you get more comfortable, you don't have to use it. But here I've made a table. I have 2 hydrogen atoms in the reactants, 2 in the products, 2 oxygen in the reactants, and 1 in the products, which we have already mentioned on the slide before. So I'm going to start by trying to balance my oxygens here, because that's what is uneven so far. So I can try to do this by, I know that I have 2 oxygens, and I have on the reactant, I have 1 on the products. So to make this 1 into a 2, I'm going to have to multiply it by 2, because the coefficient multiplies how many molecules you have. So pretend that is legible too. So now I know I have 2 oxygen, because this 2, it's 2 times the 1 oxygen. But it also changes the number of hydrogens we have now. So we have 2 times the 2 hydrogens we already had. So now that changes our hydrogens. If my mouse would reappear. Okay, sorry. Now we have 4 hydrogens, because the coefficient 2 times the subscript 2 is 4. So now we have to balance out our hydrogens, because now our oxygens are good, but now we have to balance out the hydrogens. So if we have 4 on the product side and 2 on the hydrogen side, to get 2 into 4, we can multiply it by 2. So we put a 2 in front of where the hydrogens are. So now 2 times 2 is 4, and now we have an even amount on both sides. So the 2 in front of the H2 and the 2 in front of the H2O balances it out, and you leave it at that. So it's not too tricky. There are definitely a lot trickier ones as we go on, but little ones like this aren't too bad. But we're going to have lots of practice with these. Okay, so I'm skipping through. Okay, so with this equation right here, this is something we are going to be looking at tomorrow. We're going to be looking at a lot of these things tomorrow, because I do believe you don't have any of this left on your notes. But so I know that you listened through on this video, because this is definitely an important one to listen to. I want you to go ahead and write this equation down at the bottom of the note sheet. So just write H2, N2, and H3, and attempt to balance it if you can. It doesn't have to be right, but I want you to attempt to balance it and the way that we just did. This one's a little trickier though. So make an attempt, or at least write the equation down and pretend you made an attempt, and I will give you full credit for this note sheet.